A lot of circumference. A lot of circumference tomorrow. A lot of arc length. Degrees to radians, radians to degrees. I'll give you the conversion that, actually, I'll probably just have you use your own formula sheet tomorrow. So hopefully you haven't written anything on it. You can use it tomorrow. Anybody got their, what page was that? The 4 theorems we went over a couple days ago. There you go, page 14. 4 theorems on page 14. And what we do today, there are 2 questions on what we do today, which are called inscribed angles. So don't blow off the homework tonight. All right, don't blow off the homework tonight because there's going to be a couple questions regarding inscribed angles. I'm coming pretty hard. I'm coming pretty tough tomorrow. Okay, I'm coming pretty tough. Not by purpose, just not on purpose, just because I told you. What did I tell you guys at the beginning of this unit? It's tough because all the vocabulary is new, and we've already gone through. I think this is day 7 coming up today. All right, day 6 or 7 today. All right, it's been a while since I've quizzed you on anything. If you want to know how many points, actually that's a bad idea because you can look at the video and pause it and look at the questions. I was going to just bring up the test and see how many questions, but here you go, ladies, right behind you if you want. 32 points tomorrow, okay? 32 points if anybody is wondering or that matters in your studying. All right, definitely take a look over circumference, arc length. You got 2 formulas for arc length, one for degrees, one for radians. I don't know what else to tell you other than make sure you come prepared because it's going to be a tougher one. Don't leave tomorrow saying, whoa, he was right. It was pretty tough. I'll be here today after school. I'll sit down with you. I can print out practice questions if you want me to. If you want to stop by, that's fine. Yep.
Are there any review questions on the website or anything?
I can post some. If you want me to put some underneath the circle unit on Aspen, I can do that for circumference. If you want me to do that, I can. It'll take a couple minutes. All right, so I'll do that. I'll put, because the only thing I really have extra questions wise is circumference and arc length. So I'll make up 2 different files. I'll post it under the circles folder on Aspen if anybody's interested with answers. All right, so that'll be on there. Okay, so there's tomorrow. Anything else you want to discuss, Skylar?
If you bisect an arc, do you get half the angle measure and the distance for the length of the arc?
Say that again?
If you bisect an arc, do you
Yep.
get half the angle measure and distance?
What do you, half the
Angle measure of the arc.
half the measure of the arc? Well, yeah, I don't see why. Like if you bisect a 100-degree arc, you get a 50-degree arc, right? And since you're bisecting it, it's half the distance. So just by definition, yeah. Anything else? No constructions, no proofs. Okay, no constructions, no proofs. All right. All right, let's get started then, because again, there's 2 questions on what we're doing today, which isn't too bad, but a couple more theorems though. Right off the bat, what do you guys, going into tomorrow's quiz, what's a central angle? It's got to be an angle where the vertex is the center. Is that the only type of angle though you can draw in a circle? Absolutely not. There's a ton of angles, and you're going to learn a new angle today, which is called an inscribed angle. Now the vertex moves from the center to actually on the circle. All right, the vertex moves from the center of the circle to actually on it. So what I'd like you to do while I walk around here is see you guys draw an inscribed angle in this circle where the vertex is on the circle and the 2 sides are chords. All right, the 2 sides are chords in the circle. So can you draw me your own version right now in that first circle of an inscribed angle? The vertex is on the circle and the 2 sides of the angle are chords. Draw me your own version right now of an inscribed angle. And then leave that second circle blank because I'm going to have another requirement for that one. Good, everyone's picking it up. Perfect, perfect. Looking good. Where's your vertex? That's a central angle.
Oh.
make it on the circle. All right, perfect. Something that looks like that. Here's your next challenge in the second circle. Can you make me an inscribed angle where one side's the diameter? It's a chord. Diameter is a chord, so can I make an inscribed angle that goes through the center? And where's your vertex? Still where? Still on the circle, so it's still considered inscribed even though it goes through the center. There you go. Now today's question, how do I find that angle? Review, central angle. How do you find a central angle? It's always equal to, a central angle is always equal to its arc measure, all right? Not the case for inscribed, all right? An inscribed angle is not equal to its arc measure, but it is equal to, everybody ready? Half the arc measure, all right? So the inscribed angle is equal to half its intercepted arc. Measure. Okay. Here's your first example. Why did I call triangle ABC inscribed? Why, son? Are on the circle, and it's located where? Inside the circle, right? Not outside, inside, so that's why I called it inscribed. I've given you some values, angle A, 80, arc AC, 88. First thing I'm looking for, what is the measure? Oh, hey, measure. So I'm looking for it in degrees, the measure in degrees of arc BC. Well, I can't subtract anything from 360 because I don't know all the arcs. Everyone take a look at angle A. Everyone see where the vertex is? It's on the circle. What type of angle is angle A now? What do we call it now? It's inscribed. How was angle A found? By taking half of which arc up there? BC. All right. So I got the 80 from taking half of arc BC. So what are you suggesting I do to find arc BC now? Spice this up here. Let's do it. 19, what do you suggest? Darn right. Take 80, multiply it by 2, and that'll give me the 160. Anybody confused why I didn't take half of it? The inscribed angle is found by taking half the arc. So if I want to find the arc, I multiply by 2. All right, so that was $1.60. Angle B. Inscribed, right? How do you find an inscribed angle? Take half of its arc. What arc belongs to angle B? What arc belongs to angle B? 22. What arc belongs to angle B? 88 degrees. AC, yep. So I'm going to take half of 88, also known as 44. And now to find C and D, you don't need to use any, well, maybe D, but angle C, you don't need to have a circle fact. Why don't I need a circle fact to find angle C? It's a triangle, 180 degrees in a triangle. 180 minus the 80 minus the 44. And that ends up being, what do you got for me, 7? 56. And now a couple different ways to find arc AB. Actually, 2 different ways to find arc AB. I just want to know how you're going to find arc AB now. Let's go. 2, how are you going to find arc AB? Okay, take 56, multiply it by 2, because that's an inscribed angle. Or did anybody take 360 and subtract 88 and 160 from it? Another way to do it. And what do you got there, James? $1.12. Perfect. Inscribed angle equal to half its arc. Any issues? Got it. All right, a little different. Find the values of A and B. You will now start seeing circles with multiple chords drawn in now. All right, it's going to start looking a little wacky now. with all the lines drawn in. Okay, A is referring to an arc, PT. Arc PT, that's what I'm looking for. And it's not a half circle because QT does not go through O. Somehow to find arc A. Do you see any angle measurements that I had given you in there? Type of angle is the 60-degree angle, PQT. PQT, what type of angle is that right now? 17? PQT, where's the vertex?
Oh,
It's inscribed. The vertex is on the circle and the other two sides are chords. So how did I find that angle? Half of which arc? PT, angle A. It's half of half of arc A. So what do you suggest I do there, Ella, to find arc A? There you go. So that'll be 120 degrees. Everyone ready for B? Inside the circle, is it central or inscribed? Central or inscribed? 16? Inscribed. How do I find any inscribed angle? Yep, take half of the arc measure. Now here's where some of you may have an issue. What is the arc formed by angle PRT, the one I'm trying to find? You're going to keep going there, Flo? PTS. Everyone see it? Not PT, but PTS. Are we all good there? I want to make sure we're good. That arc angle PRS forms arc PTS here. How large is that arc, Andrew? $1.50. So I'm going to take half of $1.50. Also known as 75 degrees. Ask away. Anything you want to ask there. Okay, there's an empty box there because you're going to draw a diagram either above, in it, somewhere near it, because you're going to have a new theorem that you are going to figure out for me. Circle B, please. Give me circle B. Circle B. And you can do this anywhere, all right? Anywhere you find some room. Circle B, everybody. All right, next up, I'm going to draw in chord AE right here. Chord AE. Let's throw in another chord, CD. It's going to go right there. And what we're going to do is we're going to connect C to E. Doesn't go through B, though. Doesn't go through B. It's not a diameter. And we're going to connect AD. Doesn't go through the center. How many inscribed angles do I have in my diagram right now? How many inscribed angles did we create? 4. Can you tell me anything about a pair of them? Remember how to find an inscribed angle. Remember how to find an inscribed angle. I'll give you about 2 minutes to talk it over with your group. Tell me something about a pair of these. Okay, remember how to find an inscribed angle. Okay, remember how to find it. Tell me something about one of the pairs. Any group want to let me know what you came up with? What do you got there, Nate Dog? You're coming up. Calm down, all right? So what do you tell me about angle E and angle D? Do you have something back there, Luke? Why? Why are E and D congruent? They're both what type of angles? Inscribed. And how do you find an inscribed angle every time? It's always half of its arc. So both E and D are going to be half of which arc? The same arc. Everyone see that? So they have to be congruent. Is there anything else that follows that up here? Are E and D the only ones that... Oh, now you got another pair. Go ahead. So angle A and angle C? Correct. And you guys just found out the new theorem. Why are these congruent again? They're what? First of all, they're what? Two inscribed angles. That do what? Two inscribed angles that share the same arc. So that's what you're given. What did you guys conclude? I had two inscribed angles that shared the same arc. What can I conclude then? Yep, two inscribed angles that share the same arc are congruent. Okay, so that is, I don't know what that is. There we go. All good? And just a little old school review here. What do I got here? What do I have here? Verts. What can you tell me about the two triangles here? Oh my God, I know somebody did not just say congruent. Angle, angle, angle is a way to prove congruent. Similar, yes. They're at least similar. All right, congruent. Why don't we just throw on a little side angle, right? Just like the old days, why not? Because that's, by the way, it's April 19th and it's still not a way to prove triangles congruent, so. Whew, boy. All right, let's roll. One more example and a couple more theorems and we're packing it up. Three things, three-part question. Find X, find Y, and find arc BC. And I'm looking for the measure of arc BC there. We should have put that in. AB is a diameter and ABD is a straight line. All right, let's start with X. Let's start with X. Who's got 22 here? 22. Hi, Joanna. I see that angle X is inside the circle, and the only two angles I'm familiar with are central and inscribed. What type is it? It's inscribed. And what's the theorem say? To find an inscribed angle, you take half of whatever the arc is. So let's figure out what arc X belongs to. So everyone, I always sometimes just trace it with my finger or whatever. Does everyone see the arc that it belongs to? What is so special about that arc? It's a half circle, a semicircle. And how many degrees in a semicircle? 180 degrees. Yep. So angle X ends up being a right angle. And you guys, don't get going on Y or the measure of arc BC yet. Will that happen all the time? If I have an inscribed angle drawn to a semicircle, it'll always be what type of angle? A right angle. It got to be. And that's what this theorem is saying right down here. Take a look real quick at it. Inscribed angle intercepts a diameter or a semicircle, it'll be a right angle. Every time. Okay, so if you have an inscribed angle and you're saying to yourself, hey, that's drawn to a diameter or it's drawn to a semicircle, always a right angle. All right, always a right angle. You don't need any circle theorems to find Y. 26, what's your process of finding Y here? That's what I was thinking. 26? Oh, thanks for the update. Thanks. We're just awkwardly looking at each other. Yeah. Oh, she's not here. 12. Well, how we get there, Frank? Come on. Yep, I have 2 out of 3 angles of a triangle. We're done. And what do we end up getting? 32. Got it. Okay, now we're finding the measure of arc BC. So in degrees, what's that measure of arc BC? And we just found that was 32. Thoughts here? 2. Here we go. How'd you get it there, stud? Okay, so 32 is what type of angle? Inscribed, and how did I find it? I took half of, which in this case would be what? I took half of BC, so take half of what? You get 32. You're correct, double 32, maybe. and you end up with 64 degrees. Got it. Guys, got any questions before I go over this last theorem here? I have no idea what's in this text box. You can put some nice little art there yourself later. All right, I don't know why we put it there. All right, here is the last theorem. We already went over inscribed angle to a semicircle, always a right angle. This one is huge. Do not forget about this one tonight when you're doing the homework and all of a sudden you say, how does he expect me to do this one? Look back at that theorem. Here's what it says. You have a quadrilateral inscribed in a circle. Go ahead, let me see one. A quadrilateral inscribed in a circle. Let me see it. Inscribed side, remind your classmates what inscribed means again. The vertices have to do what? They have to touch the circle, yes. So just don't have a floating quadrilateral. Have all four vertices touch the circle. Label it A, B, C, D, or whatever 4 letters you guys want. Whatever 4 letters you want. If that happens, the opposite angles will always be supplementary. So figure out in your diagram right now, like in my diagram, angle A and angle C are equal 180. And angle B and angle D equal 180 in my diagram. Maybe different for yours. Okay, please don't forget that theorem tonight when you're working on the homework. If you have a quadrilateral in a circle, the opposite angles are supplementary. Questions? All right, I will answer a couple questions tomorrow at the beginning of class on inscribed angles, and then we're getting after it here. All right, we are getting after it. Remember, I'll post circumference and arc length questions on the circle folder on Aspen for you. All right, let's get this going. Start the homework.